So now we have basically enough knowledge to do everything. There's two kind of cases that are slightly more interesting and are the more generalized form of the last case, and that is inserting before a certain target value and inserting after a certain target value. So if we want to insert after a certain target value, okay, so let's say we're like, I want to insert something after the 3, okay, right, or if you wanted to insert like the second to last one or something like that, okay, so you would get to the point, let's do that, let's say we don't want to insert into the end, we want to insert into the second to last one. Okay, and we can also do, it's the same thing with the target value. We can talk about that next, but we'll talk about this first. So I don't want to insert it into the end. I want to insert it for some reason into the second to last value. So what we do is we go through, and when our current next is null, right, just like the last time, but we don't want to insert here. We want to insert over here. So somehow we have to have a previous pointer coming in over here, okay? Now, some linked lists will solve this problem by having a node that has two nexts. One is the next and one is the previous, right? Has a reference to both, and then it's really easy. You just go backwards. And that's totally fine. But let's do this case. I mean, it's trivial if you have that, all right? So if you're in an interview or something and someone gives you that, you just be like, oh, okay, and then I just use the previous pointer or something like that. If you don't have that, then what you have to do is you have to carry along your previous pointer here, okay? And how do you do that? Well, you would make current equal to head, right? And current equal to head, right, which is this, right? And previous equal to head, okay? And then each time through the loop, okay, at the beginning, you could make current equal, or before you do the processing, current equal to current.next, okay? You do the processing on current to see if it equals, if its next is null, okay? If it's not null, then you would make previous equal to current, and current equal to current.next, okay? So how would this work? Well, let's think about it real quickly. So the first thing we have to do is, since we're gonna check current equal, we're gonna check that current.next is not equal to null, right? Because we need to have current pointing to here, right? So that previous points to here. Okay, and some students might be like, well, I want to check if current next.next equals null. You're going to get into trouble if you do that. And think about why, right? You have to check, because if head's pointing to null, that'll lead to a null pointer exception. If head's pointing to a node that's pointing to null, like there's one thing in it, then current.next will be null, and so current.next.next will be a null pointer exception, okay? And generally, right, if it's just like you're inserting after a target value or before a target value, then you still have to have a previous pointer because you don't know where that target value is going to be, okay? That's my timer. That's my timer that tells me that I'm on break right now, but it's okay. We'll keep on going with this video. That's how much I care about students. All right, so let's figure this out. Okay, let's figure this out with the previous pointer, and it'll generalize to all cases where you need a previous pointer. So if you ever come up to a case where you're like, oh, you know what would help in this situation, a previous pointer, then you can use something similar to this scheme, okay? So just to make it clear, current.next, bad idea, okay? So let's think about this. So we do want to check if it's the empty list case. So check empty list case, right? And it doesn't make sense to insert into the second to last node if it's the empty list case, so maybe it just inserts into the end here or whatever, right? This is a toy example anyways. So insert into end in this case, or insert at head, right? Okay. And then if it's the one case, let's think about that, right? So if we have one node, well, we should insert before this node, right? So it would be the same thing as inserting into head in the one node case, right? And so we could actually just call insert into head in that case because we've already implemented it, right? And that does it safely. So we've checked these two cases. That seems pretty good, all right? And if it's not these two cases, we're going to need some sort of previous pointer, right? So that we can insert into the second to last one. All right, so how do we do that? Well, we can make current equal, so we said we're going to start off by making current and previous equal to head. Okay, so far so good, right? And then we're saying, well, while current dot next does not equal null. Note that this will not cause a null pointer exception problem because we've already checked the empty list case, right? And we could even have done the one item list case, right? Because that's really easy because that's just involving calling insert at head, right? So or add to head. So this looks pretty good. All right, now we know that current next is not null, right? So we need to get to a point where current next is null, right? And so what we want to do is we want to make current equal to current dot next. But before we do that, we want to make previous equal to current. It's not going to make sense because previous already equals current right now, but we can make previous equal to current. Okay, and then we can make current equal to current dot next. Okay, let's see what happens here, right? This is a little hokey, but it's well, current dot next does not equal null. Does not equal null. Previous equals current. They already kind of equal the same thing right now. Current equals current dot next. Okay, current equals current dot next. And now we have this formation. All right, this is a very strong formation. Have you guys seen the Queen's Gambit? So current dot next does not equal null, right? So previous equals current. Okay, that looks good. And current equals current dot next. Okay. All right, so we get this like, I tore my meniscus, so this is how I walk upstairs right now, or downstairs right now. So yeah, now current dot next equals null, it does, and so now we're out here, okay, with our previous pointing to this one, right? And so now we can insert at this one. Okay, how do we insert this one? Well, we're going to take our node to insert, right? So let's say we want to insert the number 5. We're going to make sure this node points to the next of previous, right? And then we'll make sure that was my break. That was my 5-minute break. It's already over. And then we'll make sure that the next of this one points to the new node. Okay, so we'll do this first and then we'll do this, right? And make sure you do that and make sure you understand it. So we'll have one final fill in the blanks question and then that's like everything. So if you wanted to insert after or before, the important case is before a target value like 3, it's the same thing, right? If current data equals 3, well, hopefully you have a previous, right? That's pointing to this one, and then you can like insert in the same scheme we did over here, okay? And the big thing here is that we're doing this little spider web locking where current comes forward, we check it, okay, and then we allow previous to come forward and current goes forward one. We check it and then we allow previous to come forward. Hopefully that makes sense. If it doesn't, scream at me. Otherwise, I will see you in the next video. Yeah, see you later.